Is there anybody here that was not here this morning? So many of you. Okay. Since it seems that there are still a lot of people that want to see these sessions and there was simply not enough space for everybody, we are going to repeat the introduction to DAX. So this morning session will be repeated again this afternoon at 4:40 p.m. until 6:30 p.m. I have no idea where this will happen. Oh, in Regency D. See, again here. It's written. It's just me without glasses. Whereas this session will be repeated tomorrow morning at 10:10 a.m. up to 12:20 a.m. Okay? That is more for the people who are sitting in the back or the people who want to see the introduction to DAX or whatever. It's a choice whether to attend the repeating of the session. Okay, I was hoping to skip this slide, but too many people were not here this morning. Now we are going to speak about advanced DAX. Just to set expectation, this session was listed as a 400 level session on the conference. This is far from being a 400 level session. It's just the continuation of the introduction to DAX. So we will basically speak about evaluation context, row context, filter context, and then use these concepts to build some calculations, some iterations, and some time intelligence calculation. So it's far from being a 400 level session. It's just a continuation of the introduction to DAX, just to avoid people that expect to see fireworks or strange stuff, which is not going to happen at all. I'm Alberto Ferrari. I'm a consultant with Marco Russo. I founded SQL BI a few years ago, www.sqlbi.com, and there, if you search something about DAX, it's very likely that you will find the website, because there we publish all our thoughts and papers and stuff about the DAX language. The content of the session, of course, is the introductory part of the definite guide to DAX. Let's go to slides straight. This session is no, to slides. Thanks, 2 slides straight. This session is much more theoretical than the previous one. So we are basically trying to understand and get a good feeling about what evaluation contexts are. And this is the only complex part of DAX. And in my experience, it's the point where everybody stops learning DAX and try to basically, they stop. Grasping evaluation context is hard. It's much more complex than it looks at first sight. But remember, DAX is simple. It's not easy, but it's simple. So there will be nothing that I will tell you that is hard to understand. Everything will be extremely simple. The point is that when you put everything together, then it becomes a nightmare. And it takes some time before you get used to it. So evaluation contexts are simple concepts, just a bit hard to learn. We will see the basic introduction, and then we will see several examples. If you're serious about DAX, you will probably need to go farther than what we will be able to cover today in learning more details, which are in the book, they are in advanced workshop and in advanced courses. That's it. Let's go straight, and let's speak about what is an evaluation context. This slide is a question for you. That is, what is this formula going to compute? And it's a very simple question, so don't expect any trap. The sum of sales amount. That is fine. For which rows? All of the rows. And that is the most natural answer. But if it is computing the sales for all of the rows, why is it that? I mean, it's clear. I put it in the pivot table and I get all the rows. But why is that as soon as I slice by color, I no longer see the sum of all the rows? For each row, I see the sum of only that color. That means there is something else which is working under the cover. The point is that the formula says compute the sum of the sales amount column in the sales table for all the rows. but there is something, which is the context under which the formula is evaluated, that hides from the formula several rows. And basically, we can say that when we are in the first row, black, the formula tries to compute the sum of all sales, but the context under which it is evaluated prohibits the formula to see anything which is not black. So what you put in a pivot table basically filters the content of the model, showing only a subset of the data. And this something is basically the context under which the number is computed. Every number is computed into a context, and the context defines the final value that is returned by the formula. So, said in other words, the formula describes the algorithm, so what needs to be computed. But then the context defines on which subset of the data the number will be computed. And if you don't know the context, you don't know the result of a formula. That's a very simple point. But if you just look at the sum of sales amount, you cannot say what the result will be. So the correct answer when I asked you for which rows should not have been all the rows, even if I understand it's totally fine to answer all the rows. The correct answer is for all the rows that are visible under the current context. Okay? Because this context is filtering data, so what you put in a pivot table and what you can build programmatically by using DAX or Power BI, what you put in a pivot table filters the data, and so we call it the filter context. The filter context is nothing complex and nothing strange. It's just a context that reduces the number of rows that can be seen by the model. The sources of the context in a classical pivot table are four, that are what you put on the columns, what you put on the rows, what you put in the filter of the pivot table, and finally what you put on a slicer. If you use one or many slicers and you reduce the number of rows visible, basically you are modifying the filter context. Okay? Let's see an example. We have already seen some of these slides this morning. I just want to repeat their animation, and this time I will be more precise in using the correct names. If you want to compute, for example, this value, 64, the small and green, 64 has a filter context, and the filter context is green because we have green on the rows, then it's large because large is on the columns, and finally it's internet because internet is filtered by the slicer. So the only row that contains internet small, internet green and large is the semi-last one, and so this is the value shown there. Whereas if you go on the other row, which is small, then you have a green, small, internet, and the last one is the only one that satisfies the condition. Okay? What about the grand total? Well, at the grand total, this value, 240 has lost any filter from the sides, because there is no longer any filter on the column. There is no longer any filter on the rows, yet we have a filter on internet coming from the slicer. So you should think at the grand total as being computed as any other cell by scanning the model using a specific filter context. Don't fall into a trap of thinking that the grand total is computed by summing or by aggregating values which are already computed row by row, because this is not what is happening. The grand total is computing doing another scan of the data model with a different filter context. And from a theoretical point of view, every cell of your pivot table or your report is computed during a scan of the model in a different filter context. Make sense? Yeah. Cool. Now, the filter context is defined by what you put on the row, what you put on the column field, column, report, and slicer. Anything which is outside of the filter context simply does not exist. It's not there. You cannot see it in any way. And it's defined automatically. When you create a pivot table, the user, or you, if you are your user of your model, simply generates the pivot table and generates filter context in this way. Of course, you can generate it too by using specific DAX functions, and we will learn them during the course of the day. But that is the first kind of context. There is another kind of context that we already encountered this morning, and it is the row context. The row context is the concept of having a current row. We spent a lot of time this morning saying, oh, do we have a current row here? In more correct terms, we should say, do we have a row context open right now? If we have a row context, it means we are iterating over a table. And if we have a row context, we can evaluate column values. If we don't have a row context, we cannot evaluate column values. So it's defined automatically when you create a calculated column. You don't need anything. The row context is already there, whereas it is explicitly introduced by SUMX, filter, average x, any x function or any iterator will introduce a row context. And it's needed to evaluate column values. It's the very simple concept of current row. Make sense? It's everything utterly simple. Yes. I didn't hear yes. Yes, it is. The complexity is not coming right now, so let's give it time. So let's look in more detail at what happens, for example, if you do a SUMX over orders of quantity multiplied by price. The title is the measure we want to compute. And imagine that I want to compute the grand total, 592. What is the first thing that the engine needs to check? What is the first thing that you need to know in order to compute this value? Louder. I know very well the technique that I used when I was a teenager of answering with a low volume of voice. So the teacher doesn't hear and say, oh, you must have said it right. That's not going to work. I'm too old for that. And by the way, I'll repeat your answer in a few seconds, which is right, of course. It's nearly the answer to all of the questions I'm going to ask this afternoon. So now that you're done, it's very easy. The first thing that you need to check is the filter context, because this is filtering the whole data model. So you need to understand what the filter context is here. And we have no filter on size, no filter on color, still a filter on internet. So the filter context will contain only the last 4 rows. And this is the data set that is visible when your formula starts to compute a value. Then SUMX kicks in and says, oh, I need to iterate the orders. That doesn't mean iterate all the orders, but only the orders visible in the current filter context. That is 4 rows. It goes on the first row. That is, it opens a row context on the orders, goes on the first row, performs the calculation 16 multiplied by 7, put the result aside, and then goes on iterating over the table and computing the value one at a time, putting them all one on top of the other. At the end of the calculation, it sums everything, does a sum, an average, or whatever aggregation is required, and then puts the result there. Okay? And that's what happens whenever you compute the value cell by cell. Remember that there are always 2 contexts, and the 2 contexts have nothing to share. There is the row context and there is the filter context. The 2 are different and they do different things. The row context provides a single row, whereas the filter context filters the data model. I told you that I was going to be pedantic, and I'm just starting. Both are what we call evaluation context. So the evaluation contexts are only 2, row context and filter context. The row context might not exist in a standard measure. There is no row context. And the filter context might be empty, meaning that you can see everything at the grand total of any pivot table, or if there is no filter at all. But this seldom happens because you are not interested only in grand totals. Of course, I'm so interested in filter context because working with evaluation context is the key to most, if not all, of the measures and calculations that you will do with DAX. And learning how to master them requires some time. Let's see, again, with the correct terms, what is happening when you filter a table. The measure now is a bit more complex. It's SUMX over filter of orders where orders price is greater than 1. Some X requires the result of filter. Filter needs to scan the orders, but it cannot see all the orders. It only sees the orders which are visible in the current filter context. And imagine that we are at the total for green. The filter context is green internet. And because it's green internet, it only filters the last 2 rows. Then at this point, filter opens a row context on top of the orders table. It iterates over the 2 rows. The first one survives the filter. The second one does not survive the filter, so it's going to be removed by filter. And finally, some X goes on iterating over the result of filter and produces the final result. The question for you, the first one is, we know we have a row context here. We already discovered that this morning. But do we have a filter context here in the box, the order price greater than 1? I always need to show that twice. I see somebody saying yes, somebody saying I don't want to answer. And what is the filter context at that point? Greater than 1 might be. Any other answer? The previous filter. Other kind of answers? The current row. So basically, ask yourself, do you see anybody that changed the filter context? Greater than 1 is a condition that is created by filter by iterating over orders and is used to remove rows from a table. Okay? The filter context was there at the beginning, and some X is not changing the filter context. Filter is not changing the filter context. The filter context only hides rows from the model. So it removes rows from the model. And not a single function here is able to change the filter context. They will fill the filter context. They will not be able to go outside of it, but they are not going to change. So right now there we have a filter context. We have a row context introduced by filter over orders, and we have a filter context which is the original filter context of the pivot table, because not a single function here changed the filter context. No? Orders price greater than 1. Sorry, the question was, does this filter context excludes rows that are greater than 1 or smaller than 1?
Exclude the ones that are equal to 1.
Or 1 that are equal to 1. No, the point is, the filter context is created by the pivot table. Okay? Filter and some X do not change the filter context. That's not what they do. Some X iterates over a table and does a calculation. Filter scans a table and returns a result. But neither some X nor filter change the filter context. Okay? So the filter context is always the same. Nobody changed it. Filter returns a table. So it scans orders and returns as a result a table. That table does not contain rows where the price is strictly greater than 1. But the filter context still contains those rows. They are there. If you want to access them, they are there. It's just filter that is not returning them. Okay? Do not make confusion between filter context and the iterative nature of table functions or table functions that return table. They have nothing to share. The filter context is a concept, which is a huge filter on top of your model, while filter, iterators, and all this stuff have nothing to do with the filter context. We will find a function that is able to change the filter context, but it's coming in a few minutes. Yep?
Is it valid to say that the filter context was applied to the table function prior to the table function executing?
Is it right to say that the filter context is applied to table function before they are executed? Yes. You can think, the easiest way to think of the filter context is when you read the DAX expression, replace all the table names in your mind by adding as visible in the current context. So this is saying filter the orders visible in the current context, and return me the ones where the price is strictly greater than 1. Okay? It is not changing the filter. It's just reducing the number of rows. We spoke about all earlier, and again, I want just to be pedantic with all. All does not change the filter context. All ignores the filter context, which is something totally different from changing it. So when you want to evaluate that cell, the filter is still green internet, so the last 2 rows. All wakes up and says, oh, I should see only 2 rows in the orders table, but I'm much more powerful than the filter context. I'm going to ignore everything. And so I always return everything. Okay? That said, during iteration, here SumX opens a row context on all the orders, so it sees all the row orders. It computes orders amount for every row. But keep in mind, the filter context is still there. Nobody changed the filter context. One thing which is not unique about the row context, but it happens typically only with the row context, is that the row iteration can be nested. You can do an iteration, and then inside the iteration you do another iteration, and then inside that iteration you open another one, and that's totally fine. You can do as many iterations as you want. But that means you iterate over categories, then over the products of the category, and then over the sales of the product of that category. So right now, when you're here at the ellipsis, there are 3 different row contexts open on 3 different tables. And again, there is nothing wrong with that. But you have a row context on category, another row context on product category, and another row context on the sales table. All of them are living at the same time. That is not a problem, and it creates no ambiguity at all. Now, the next point that I want to do with you is an exercise that we can do. I think the easiest thing we can do is doing that together by throwing ideas. Instead of writing on your PC, it's probably better if we reason about it together. Imagine that I'm a customer, and I ask you to create you have a table, contains product key, product name, list price, and I want to have a column, a new calculated column in the product table that contains the ranking of the product based on the list price. So the most expensive product should be ranked number 1. The second most expensive product should have a ranking of 2. The third most expensive product should have a ranking of 3, and you got the game. It's just ranking by product.
Rank X.
Makes sense? Did I ever speak about rank X? So from your point of view, it does not exist. Besides, you can solve it with rank X, but with the tools you have so far that does not contain rank X and anything like it, how would you compute such a measure, such a calculated column? Maybe we can, the problem is clearly set, I guess, so you know what we want to compute. We can move to the demo machine and then build the measures together. So we only need to go on the product table. We can get rid of some columns just to have a bit more real estate. Okay. Let's remove also the unit cost. So we now have more space, and we can go to modeling a new column. Ranking on unit price. Oh, don't write, because I want to hear your voice now. It's not a matter of writing, it's a matter of thinking. How would you compute it?
Calculate
count the number of rows. That's the first time I get the first answer as the first time. Yep. In order to compute the ranking, typically people answer saying, oh, you take the distinct count, or you sort them by list price. In reality, the algorithm is much more simple. What you need to do is simply, given a product, you simply count the number of products that are in the same table with a price which is higher than yours. Make sense? If this number is 0, that means you are the most expensive product. If this number is 1, then you are the second most expensive product. If this number is 2, blah, 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 blah. You got the point. Okay? We know how to count. We know how to filter. We have everything we need to do it. Nearly everything. So we need to count, and we do a count rows. We don't want to count all the products. I hate you. We filter the product table. Before writing the full measure, let's do something easier, just to check that the syntax is right. Where is greater than? The product where the unit price, let's say, is greater than 100. This is going to return for all the rows the same value, that is the number of products which have a price greater than 100. Okay? And if I hit enter, I get the result, 1728. There are 1728 products which have a price greater than 100. Now, what I need to do is now replace that 100 with the current list price. Make sense? Say yes or no, just keep cool. And I'm in trouble right now because do we have a row context here where the cursor is blinking? Who said no? We don't have a row context there? Filter, remember, is an iterator. We have, first of all, we have a row context coming from the fact that we are creating a calculated column. And then we have another row context, which is created by filter while it iterates over product. Make sense? So we have in reality two row contexts open at the same time. They are nested one into the other. The problem is that the row when I write product unit price, to which row context I'm referring to?
The filter's row context.
The row context coming from filter, which is the innermost, the nearest one. So I have two row contexts. Both are open on the product table, and the innermost one is hiding the previous one, because they are on the same table. And so when I write product unit price, I'm referring to the price of the currently iterated row by filter over product. And what I want to do is compare this value with the row context that is outer, the outer one, the previous one. Make sense? And the point is that I cannot write product unit price here. I need something different. There is a function that has one of the worst names that could have been chosen, which is earlier. Keep in mind that the original name of earlier was outer. And as outer, I understand it much better because I have a nesting of row contexts and they go out one level. Instead, they call it earlier. What earlier does, earlier simply gives you access to the outer row context. So it says, I want the value of the unit price, but I don't want the value iterated by filter. I want the value iterated by the previous iteration, by the outer iteration. Make sense? And if you write the formula in this way, you get something that reminds at least a ranking. What's wrong with you? Oh, I need to sort by unit price, otherwise we don't see values. Okay. Well, it's not really correct because we need to add 1. Now we see 1, 1, 1, and all these products have the same unit price, and this is showing 1 for all the rows. Okay? And then for the first row that has a slightly lower price, we see 15, because there are 15 ties before that. Make sense? Now imagine you propose this solution to your customer. And you say, well, of course 15 comes after 1, so it's a good ranking solution. If the customer says, okay, I want to meet him because he needs to be a really good customer, typically people say, no, I don't want to see 15. I don't mind how many ties are there. I want to see 2 there, because ranking is 1, 2, 3. So how would you change this formula to compute 2 instead of computing 15? Louder. Distinct of what?
Of the price of the rows.
Of the rows? Of the prices? Okay. Elaborate on that. I mean, distinct of unit price is not an answer yet. A bit more. Louder. I'm also far. What this function is doing, it's computing the products which have a price greater than yours. We are not interested at all in the products. We are interested in the prices higher than mine. Now, do we know a function that is able to return, instead of all the products, all the values of the product unit price? The answer is yes, but now I need somebody to tell the function. All. You iterate over all product unit price, and now this is a completely different algorithm. It says, oh, get all the values of the unit price, iterate over them, and now no matter how many products have the same price, they will only count for 1 row in all unit price. And so the result will no longer be 15. At this point, the result will be 2. So I have 1 with all the ties, and then 2, 2, 3, 4, 5, and so on. Make sense? So there are 2 things here to know. The first one is the usage of earlier, and the second one is the usage of the way of computing these values in DAX. Now keep in mind that earlier is considered one of the most complex functions in DAX. Because I don't really understand because. It's not easy to grab at first sight. But the point is that if you think in terms of row context that can be nested, the earlier is pretty simple to use and understand. Nevertheless, everybody hates earlier, including myself. So you can get rid of earlier if instead of using earlier, you use variables. You remember that we spoke of variables this morning. And what you can do is define a variable, and you call it current list price, which is equal to the product unit price. Once the variable is defined, I'm doing damages, then you return a count rows of filter of all product unit price that are greater than current list price. If you write it in this way, it's much easier to read, it's much easier to understand, and probably it gives also a sense to the previous version we did with earlier. Because if you write product unit price outside of filter, then the only row context which is open is the one of the calculated column. So that is the product unit price of the current row. whereas product unit price inside of filter is the currently iterated row by filter over all product list price. So now that we have variables, you can forget about earlier and start using variables instead, because they make the code much easier to write, to read, and to debug. And besides, by giving names to the values that you use, the code is also much better to use and write. Variables are available in Power BI, and I think they are available also in SQL Server 2016. They are not available in SQL Server 2013. Okay?
Quick question.
Yep.
So will this variable be available globally across our whole Power BI file?
No. The variable is defined locally. The variables are defined locally to where you use them. So any DAX expression can start with var and define a variable which is local to that expression, but then it's lost outside of it. We would love to have global variables, but they are not there. Yes? Well, in that case, using values, all, or this thing, they all provide the very same result, because the only difference will be the filter context, but we don't have any filter context here, so that's not an issue. Okay? Let's go back to the slides, please. Now, this is just in the slides as a reminder for later. We write the version with earlier or the version with variables, which is much easier to read and use. But it's available only in the newest versions of the DAX language. Now it's time to speak about calculate. I typically call calculate the queen of all DAX functions. So somebody already heard it. And I call it the queen. I really think at calculate as a queen, not as a king, because I really think calculate is a woman. That means that you will never totally understand her. Yet, it's incredibly powerful. And I was scared. Before saying something like this in the US, I know you are mad with sexual harassment. But I mean, being Italian, I'm not expected to even understand what sexual harassment is. So it's fine. And besides, after what the Xbox guys did last few days, I don't worry anymore about what Microsoft would ask me. Why calculate is powerful? And why calculate is complex? Because calculate is the single only function in DAX which is able to modify the filter context. No other function have the same power. Calculate is the only function that is able to take a filter context, modify it, and create a new one. Remember that all the other functions obey to the filter context. Calculate is much more powerful. Calculate is able to modify it. And the syntax of calculate is extremely simple. You write calculate, then an expression. The expression can be whatever you want, any DAX expression. And then you provide a set of filters, one after the other. All the filters are evaluated, put in a logical end together, and used to create a new filter context. We will see a lot of examples of calculate usage. So what you can do is write an expression, which is, by the way, extremely easy to read, like this one. Calculate sum of sales amount where sales amount is greater than 100. This is different from filter. This is very different from filter. Because now what we are doing is calculate, wakes up, it evaluates sales amount greater than 100. It builds a filter that says, let's get rid of all the rows in sales amount which are not greater than 100. Then I will apply the filter to the model as a filter context. And finally, I compute sum of sales amount in the newly created filter context. Okay? So this time, sum of sales amount is still the sum of the sales amount column in the sales table for all the rows visible in the current filter context, where the filter context is the one generated by calculate, adding the condition that sales amount need to be greater than 100. Okay?
So it ignores the pre-existing filter context when
not yes and no. It will replace any existing filter on the sales amount column only. Any other filter will be kept alive, but if you reach this formula when there is a filter already applied on sales amount, that filter will be thrown away. Okay? The first thing that you need to always remember, because it's important, and it would have helped me a lot at the beginning, is that the filters of Calculate are not conditions. You read them as conditions because it's easier and it's simple to read them as condition. But in reality, the filters of Calculate are tables. You can pass to Calculate a table as a filter, where the table identifies the good values for the column. So when you write Calculate sum of sales quantity where unit price is greater than 100, this is equivalent, meaning that is internally converted into a more complex expression that says calculate the sum of sales quantity and filter all the unit price where unit price is greater than 100. And the important part of this filter is this all. It's not filtering the values of unit price, it's filtering all unit price. So it first removes any filter from the unit price column, and then it replaces the filter with a new filter that shows only the rows where the unit price is greater than 100.
When the expression is being calculated, is it converting the syntax of that upper function
into the lower one, yeah. From a functional point of view and from a performance point of view, they are the very same. This is just easier to write and to read. But when using this or using that, it's the very same. It's just syntax sugaring. It's easier to write a condition, but in reality, it's converted into a table. Okay?
It does have a row context, the filter.
Here we have a row context, which is introduced by filter over all, then filter terminates its execution, and when filter terminates, that set of values is used to build a filter context that is then used to compute the sum of sales quantity. Okay? So, for example, if you want to compute the sum for all the colors, you simply calculate the sum of sales quantity for all product colors. Now, it might be useful to go back to the demo machine and write a couple of measures so we see the result of computing these values. Can we switch back to the demo machine, please? Okay. I did some damage. Fix this. Okay, so easy. Just click on fix this and that's it. So now we have an empty report. Let's remove some stuff. In reality, let's remove everything. It's easier. Okay, let's put the color, for example. And we take the sales amount. Okay, so we have sales amount divided by color. Sales amount should be a measure, I guess. Yes, it's a measure that computes the sales amount. Now let's create a new measure, which are sales in red. We can do that from here. New measure. And let's call it red sales, which is equal to calculate sales amount where product color equal red. Now, before you hit enter, otherwise that's so easy to answer, what number will I see a result? Always the sales of red products, or only the red value when red is already selected in the pivot table or in the report? Who says the same value everywhere? Who says red only when red is selected? You and half, because the hand doesn't go all the way up. Then it's full of blank results, blank values. Think of what the calculate will do. Calculate will wake up and say, oh, I'm gonna evaluate product color equal red, so I filter all the colors and I return only red. So imagine that you are computing the value here for brown. When you reach this point, the filter context contains brown. Calculate wakes up, replaces the filter on color, brown, with the new filter on red, and then it computes the sales amount. So the final result that you will obtain is always red. Now, of course, I need to add the measure. Now, I really wish I knew where I defined it. Can you see red sales anywhere? Oh, here it is. Perfect place where to put it. Okay, and you see that you see 126 for all the rows. Okay? Keep in mind that if you add more filters, for example, you filter by brand too, the filter on brand is not overridden. So what you see in red sales right now are the are here. Sales amount is the sales of black litware, while 19,450 is the sales of red litware. Makes sense? Because the filter on the brand is still active. We are replacing the filter only on the color. Make sense? Now imagine that you want a different measure because you don't like the behavior. So let's get rid of this. And instead of seeing red sales in this way, customer, you told me, yes? I now want a different measure that shows red only when red is already selected. Otherwise, I want it to show a blank. How would you modify the code to make it work to show only red on red and avoid showing values when red is not selected? Go ahead. Okay, so use filter. I'm your finger. Just tell me and I will write.
You're going to go calculate sales amount. I don't know how to say it right.
Okay, the idea was not bad.
I'll do the sum of sales amount.
Okay, sum of sales amount is already here.
Yeah.
Sales amount is a measure that computes the sum of sales amount.
So I'll do some of that. And then create a filter on the color. There is a red.
Elaborate on that. Imagine that you are writing it.
Yeah, so after calculate, you can write the sum. And then there is a bracket for that. Yeah. And then finish the bracket after the red.
That is not going to work. Go ahead speaking. I hear a hand, but just go speaking. Don't worry.
Sales amount you filter, and then product color equals red.
You try that on your PC. Filter, I guess it probably is going to work even without anything. Okay. If I write it in this way, apart from the fact that product is a keyword, and you can imagine how I hate product from being a keyword because it appears everywhere, now it's working. So it's filtering only the products and shows red only, so shows sales only where red is there. Why is doing that? Where did I told the engine what is happening to obey the filter context? I'm looking at you. You provided the answer, so the point is, why is it working?
Because it is telling it to pay attention to the, it is telling it to pay attention to the context.
Okay, but where is it doing it? There was a hand somewhere there.
When you're referencing product, that reference to the product contains the filter context.
There, you're saying filter the product. And in your mind, you always need to replace product with the product as visible in the current filter context. So this is not filtering all the products. It's only filtering the red products if red is selected. And it's filtering the black products if black is selected. It's filtering the green, yellow, or whatever color, because you wrote products there. If instead of product you write all product, then you get as a result the previous result, because now you are saying don't filter only the currently visible product, filter all of them. And so no matter what you choose as a color, it always shows the sales of red. Make sense? Okay. Now let's go back to slides, please. So you can write, for example, sales of red products by computing. Here I'm writing sum of sales quantity. On the demo I used the measure, but that's the very same. You can write whatever expression, whatever DAX expression you want, and that returns you some result. It might be interesting to know that we did it very naturally, but it hides some complexity. The fact that we place the filter on the product color, and then we perform the calculation on the sales table. So the filter is done on one table, but calculation happens on another table. So there should be some kind of automatic filtering happening, and we will go back to that later. Since all the conditions that you put in calculate are put in a logical AND together, if you need to use an OR condition, then you need to merge into a single condition two different sets. So if you want Italy and France together, you do a calculate of sum of orders, well, that is a mistake, quantity, where country is equal Italy or France, and these two conditions should be put in the single condition, because if you split them as two different conditions, they will put in a logical AND, and as a result it will always be empty, because there is nothing which is Italy and France at the same time. Make sense? And not all, but in general, calculate is powerful and it is very useful because it lets you remove and replace filter in a very granular way. You can remove and replace filters at the column level, where every column can be handled separately. For example, in this slide, I'm creating a measure that I called all channel, that removes the filter from the channel, but still keep the filter on the sides and the filter on the color. So filter on sides and on colors are kept, filter on channel is removed. And if you remember the slides we saw earlier, there was always the same value for all the cells, because using all at the table level and without having the power of filter context, you typically have the option of removing all the filters at all, or keep all of them. Whereas with calculate, you can remove filters from only one part of the filter context, working in a very granular way. So it's extremely powerful. How does this work? When you write calculate sum of orders amount for all orders channel on this model, imagine that you want to compute this value. The first thing that you need to check is the filter context. The filter context there is green internet, because we have a filter on channel and we have a filter on green. So on the last two rows. Then calculate wakes up. Before computing this part, it evaluates the new filter that says, oh, you want to consider as valid values any value for the channel. So I will compute all the values of the channel. I create a distinct of those, and so I get store and internet. Then I remove the filter from the channel, but I will keep the filter on color because the filter on color is still there. And so it adds these two rows to the filter context so that sum x does not iterate only 2 rows, but it will iterate 4 rows. Make sense? Yes. Okay. So calculate is extremely powerful. The only it's not a drawback. The only point is that being able to modify the filter context, you need to check at different points and at different parts of the formula what is the current filter context. So what does calculate do? Calculate can partially replace filter context, modify the filter context, and can replace a whole table, or it can replace a single column. And it's the only function that works on the filter context. It has another small thing, but we will see that later in half an hour, I guess. We saw before that you can apply the filter on dim product and then compute values on the sales table. So there should be some kind of automatic filtering happening. And this is the part that we need to understand. Imagine that you have a data model like this one. That's a very simple star schema that contains, as usual, sales, product, customer, customer, sales, product, category, and subcategories, and then finally categories. It's a snowflake. Now imagine that you create a filter context on dim product category. Do you expect the filter to be propagated to other table, or do you expect the filter to stay there and filter only one table? It might stay there, it might be propagated. We don't know that yet, but we'll discover it in a while. And that is for the filter context. What about the row context? Imagine that I start iterating the sales table. And if I iterate the sales table, what I expect to see in the product, in the customer, and in all the related tables. I will have a current row also there because I'm iterating, or the current row is limited to only the table on which I have an open row context. Since we have two kinds of context, the row context and the filter context, and we have two roles of a table in a relationship, I can be on the one side or on the many side, we have in reality in total 4 different cases to study. Row context on the one side, row context on the many side, filter context on the one side, filter context on the many side. Okay? So there are not too many. It's easier to run through them and understand exactly what DAX defines for each individual point scenario. The row context, we have already seen it this morning, but it's easy to repeat it. The row context is the easiest one because the row context simply does not care at all about relationships. If you create, imagine that you have a relationship between orders and channels. And in the orders table, you write orders amount multiplied by 1 minus channel discount. Even if there is a relationship, we already know this doesn't work. We tried it this morning, and it simply doesn't work. If you want to let the row context be propagated through relationships, then you need to be explicit about that. And you need to use the related function. The related function. Related basically takes the current row context, follow a chain of relationships, and reaches the target table, creating a new row context on the target table. It looks very complex. In reality, it's just a relationship to follow, so it's more complex to describe, but in reality, it's extremely fast. So related when you are on the many side and you want to reach the one side, and on the opposite side, we already know you use related table. Related table lets you get access to a table containing all the rows which have a relationship with the current row context. So the row context is pretty simple because it basically totally ignores relationships. And if you want propagation to happen, you need to be explicit about that. The filter context, on the other hand, has a totally different behavior. The filter context propagates through relationships And it does it in two ways, depending on the version of analysis services you are using. In SQL Server 2013 and in Power Pivot up to 2016, it propagates only from the one side to the many side. It does not propagate from the many side to the one side. In Power BI and in Analysis Services 2016, but not in Power Pivot, you have the option of defining which way the filter context will propagate. And so you have more power and you can define more complex expressions. But the point is that the behavior is totally different from the filter context. Let's focus on the easiest part, which is let's stay with Power Pivot, or with the Power Pivot behavior, and the filter context propagates from the one side to the many side, but does not propagate from the many side to the one side. So imagine that you have a data model which now is a bit more complex than before because it contains two tables. And the two tables have a relationship. We have cities on top and orders at the bottom. And we have a slicer on the continent. The continent is one of the columns of the cities table. We have a slicer on the channel, and then on the rows I have the color, and on the columns I have the size. Okay? Now, the slicer on the continent is selecting North America. Because it's selecting North America, it's a filter context which is applied to the cities table and shows only North America. So there is only a single row visible in the table. But it's a filter context. And a filter context, as soon as it sees a relationship, it jumps on it and propagates over all the related table. So it will reach the sales table and filters only the rows which belong to cities in North America. Finally, that number will be put in the pivot table with other slicers and filters. Make sense? If you think of that, it's very intuitive, it's very natural, and it's the very reason why pivot tables work. If that wasn't working, you couldn't filter a product and see the sales of only those products. That happens only because the filter context is propagated automatically from the one side to the many side. Now we have selected North America. Imagine that instead of selecting North America, we select Europe. If the slicer selects Europe, then on the cities table, we no longer have an individual row, one single row. Now we have many rows, which are visible because they are all the cities belonging to Europe. Doesn't really matter how many rows we have selected here. We are on the one side of a one-to-many relationship, so the filter context jumps on the relationship and will filter other table. So it will show the 3 rows in the orders table that are related to visible rows in the cities one. And then, because there are still filters on green, red, large, small, all those numbers will go in the right place depending on other points of the filter context. But the important point is following this jump from the city to from the column in the cities table to the cities table, and then from the cities table straight to the fact table. And that happens automatically. You don't need to do anything. But that happens automatically because it's a filter context. So as you can imagine, whenever Calculate creates a new filter context and applies it to the data model, this propagation happens automatically. And this is where Calculate starts to make everything a bit more complex. Because Calculate creates a filter, put a filter on the table, but that filter can propagate in different places of the model, having side effects that are not hard to predict, but you need to take them into account to understand exactly what is happening and what number is being computed by your model. Okay? Let's try it again. Okay? Yeah. Cool. You know, it's after dinner, after lunch. I'm worried that you start sleeping at any time. And besides, this is not really soft thing. So this is the same diagram we had before. The filter context propagates following the available direction of each relationship. So in Power Pivot, you can only follow the relationship from the one side to the many side. in Power BI Desktop, you have the option relationship by relationship to tell how the propagation happens. As a very simple word of warning, keep in mind that the bidirectional relationship, this way are called the relationship that filter both ways in Power BI, are probably one of the most dangerous features that Microsoft ever built into a modeling tool, because it's extremely simple to build a model that generates numbers that have no meaning at all because of this propagation of filters. So you start generating a model, and it's very easy to build a model that computes number that the user simply cannot understand. So before using bidirectional filtering and thinking that you can enable it everywhere and everybody's happy, think more than once and study really carefully what is happening with your model. Because I do it for my job. I created models which are really impossible to understand. You look at the numbers and say, well, I have no idea what is being computed now, because the chain of relationship is so complex that it's no longer human readable. Anyway, for simple star schemas like this one, everything is much simple, because if you put a filter on dim product category, you are on the one side of a one-to-many relationship, so the filter is propagated to dim product subcategory. From dim product subcategory, it is again propagated to dim product, and then from dim product, the filter is able to reach fact sales, and all of this happens automatically just because it's a filter context. Now that it is in fact sales, it stops. The filter does not go to dim customer. Make sense? It's useful to see that. If we go back to the demo machine, please, we can easily take a look at the behavior by creating a very simple measure. Let's get rid of red sales, and let's create a new measure which is simply count rows. Let's call number of customers, which is count rows of customer. Okay? Now, this measure is computing the number of customers. If I get rid of the color and I put, for example, the marital status, and then the number of customers, you see that I see numbers which have some meaning. 10,000 are married, 10,000 are married, 8 are single, and 385 we don't know. So these numbers make sense because the filter is applied to the customer table. I'm computing values on top of the customer table, and everything is working fine. But if instead of filtering by marital status, I filter by product color, you see that the number here is always the same. And if you look at the data model, the filter is on the product table, one side of a relationship. So the product table will filter sales, but then sales has a many-to-one relationship with customers, so the propagation stops here. That is, the filter on product does not reach the customer. Okay? And this is all what you have in Power Pivot. In Power BI, you can choose the cross-filter direction that can be single or both. Single means that the propagation happens as in Power Pivot. Both means that the filter is able to propagate from the many side also to the one side. And with this setting, now you see that this number is totally different. Now this is the number of customers that bought an Azure product, or a black, or a blue, brown, gold, or whatever. Okay? So if you enable bidirectional filtering, then the filtering happens everywhere. If you keep it disabled, then the filtering happens only from the one to the side.
What are the risks of enabling it both ways?
The risks, well, the point is, first of all, by enabling bidirectional filtering everywhere, in a star schema you don't have any issue. So if you build a pure star schema, you can enable it everywhere. You are only paying a very high price in terms of performance, because applying the filter from the one to the many side is very fast. Yes, from the one to the many fast. Applying it from the many to the one is much slower. And basically, you are transforming all the relationships in many-to-many ones. And many-to-many are extremely slow. So the model might be slower than before. But this is a price that you might be willing to pay. So you have a few 100 million rows. The model is pretty simple, straight calculation, so you can enable it everywhere. The point is that I don't have any pen here to write it down, and I don't have slides ready. But it's very simple to create loops in the set of relationships. So if your model is not a star schema, but it can only just contain 2 fact tables, or it can contain a diamond shape, or it can contain multiple relationships between tables, and you enable bidirectional filtering everywhere, you very easily reach a scenario where the model becomes ambiguous. So the engine does no longer know what to filter, because it can follow too many paths. And so you put a filter on one table, and that filter can go in different places and reach through different paths the same other table. So it doesn't know which road to take. And in that case, the engine will tell you, I'm sorry, the model is ambiguous. You need to disable bidirectional filtering somewhere, or you need to remove, you need to disable one of the relationships. When you reach this point, it's very, very easy to create models where the path followed by the relationship is not the most intuitive one, and it becomes a bit more complex. I wish I had the slides to show you, but unfortunately I don't have them prepared. It's not something we can discuss just by looking by imagination. But if any of you is interested in that stuff, we can stop outside later, and I will show you the details of when this becomes dangerous. I just don't have my PC here, so I cannot show that.
What is the total number of customers once you filter it that way? Almost 19,000, but it isn't the sum of the top of the row.
So you are asking me why the number? I need to see it, otherwise. No, that is number is okay. 18.
Put it back to the vote.
Okay, and if I go back to the previous one, okay. Oh, this number is larger than the individual ones, because I have a lot of customers who never bought anything from me. So what I'm seeing here, the filter started from Azure. Azure is hateful. Let's say it started from blue. So it starts from blue. It reaches the fact table. Then the fact table will filter the customer table. So you are seeing only the customers who bought blue products. Okay? At the grand total, the filter on the color is gone. So there is no filter on the color. That is, there is no filter on the fact table. There is no filter on the customers. So you see all the customers, either they bought anything or they didn't. Make sense? And the two numbers, of course, are totally different. So you cannot grab them by sum. And keep in mind that this is always a many-to-many relationship. So it's very likely that the same customer both bought black and pink products. And so it will appear in multiple places. So you might find a lot of scenarios where the grand total is larger than the sum of the individual rows, because it's a many-to-many relationship. And it's something you need to get acquainted to. It's not extremely intuitive at the beginning. OK, let's get back to slides then.
Alberto,
Yep.
so if I want the number to match, I need to change my measure to make sure that I count rows of customers who have made at least one purchase. Is that correct?
Yep.
But it's still
But
not
it still
like
don't count, so it still won't necessarily add up, right? It could still say one customer bought black and they also bought blue, so that would add up to different amounts. So that
Well, in that case, you need to iterate over the colors and then sum the individual values if you want the total to match the sum of the individual ones, which doesn't really make a lot of sense.
You could do a distinct on the customer. Right.
yeah, but if they bought
It's already happening, the distinct on the customer.
Not if you do distinct
grand total level, but at the color level, when it's breaking it out, it's still gonna tell you that the customer bought this and this in both rows.
Right.
So at the grand total level, that would work. If you want the grand total of each customer.
Okay? One of the consequences of how calculate works is that you cannot write expression like the first one. Apart from the fact that it's totally stupid to check that quantity multiplied by 2 is less than the price. But forget about that. The point there is that we are using two different columns from the same table in the same expression. Now, imagine that I reach this calculate with a filter on quantity or with a filter on price for whatever reason. What is calculate expected to do? It can replace the filter on quantity, it can replace the filter on price, it can replace both of them, or it can replace none of them. There are too many options, and they went for the easiest one, which I agree is the correct one. That is, you cannot even write this expression. If you try to write it, the engine will tell you that your reference is two columns in the same Boolean expression in calculate, and this is not allowed. If you want to do a test like this, you need to move to a table, to a filter on the full table that says filter the orders, only the ones visible in the current filter context, and return me the one where quantity multiplied by 2 is less than the price. So you apply a filter on the table, and now it's your responsibility to decide whether to remove or to keep filters on the table. Calculate doesn't do that for you. Okay? The last thing about calculate is context transition. Context transition, oh my God. Context transition is a beautiful feature that either you will love or hate. Typically at the beginning you will hate it, but then after some time you start loving it. Calculate does another important task. That is, whenever it is executed inside a row context, it will transform the row context into an equivalent filter context, and then it destroys the row context. The way I think at it is that calculate hates row contexts. So she wakes up and says, oh, is there any row context around? If yes, I'm going to destroy them. But since I'm a fair function, and I don't want to break your calculations, I will replace them with an equivalent filter context, so that after I executed, only filter contexts are around. All the row contexts are gone. If we go for a while to the demo machine, I want to show you okay, a very simple test. Don't do that on your PC. This time I will ask you very, very simple questions, and I expect you to answer without looking at the result, because otherwise that is too easy. Okay. Now, on this data model, we are interested only in sales and products. Okay, so forget about all the rest. Focus only on sales and products. And I will create a new column in the product table. I call it test, which is equal to sum of product unit price. And that's it. It's a very simple measure. Then I'm hearing fingers writing. So that is the column. It's a calculated column. It contains sum of product unit price. And the question for you is, what number will appear here as soon as I hit enter?
The same number for every row.
It's on the row context.
We have the same number for every row as an option. We have the same value that you see there, so the same number. Any other option? Typically, the three options are the same number for all the rows, the same number of the given row, or error. Who says the same number for all the rows? Who says the same number for the given row? Oh, few people. Cool. What sum does? Sum computes the sum of the product unit price for all the rows which are visible in the current filter context. Do we have a filter context here? No. We have a row context. Who cares about the row context? Sum ignores the row context. Sum uses only the filter context. And so as a result, you see the same number for all the rows, which is the sum of all the products. Okay? And now we call our best friend and say, oh, now let's try calculate sum of product unit price. What is going to happen? Louder. We have a row context. Calculate wakes up, says, oh, is there any row context around? Yeah, there is one on the product table. And it says, oh, I hate row context. I'm going to destroy that. But I'm a fair function, so I will replace the row context with an equivalent filter context. And then I apply it. So when the filter context is there working, sum will start and say, oh, how many rows do I see in the current filter context? And it is only one, because calculate removed all the other rows from all the other, because it transformed the row context into a filter context. Make sense? Now let's do the same with the other table. Sum of sales quantity, or whatever, any column from the sales table. What number will appear? Louder. Total quantity for that product or total quantity for all the products? All the products, because there is no filter context working. And so this is showing the sum of all the products. Trust me, this is the sum of quantity for all the products. Doesn't really matter the number. Now let's try with calculate. What is going to happen now?
One to many. It'll be the sum of all the sales for that particular product.
Because there is a row context, the row context will be transformed into a filter context by context transition happening because of calculate. And now it's a filter context. And the filter context says, oh, is there any relationship around? Yeah, there is one going from the product to the sales table. I'm jumping on in, I'm reaching the sales table in order to show only the sales of the given product. And so what you get as a result is a different number, which are the quantities sold for that product only. Okay? That's an interesting question. No, you use related when you already have a row context. What is totally useless is related table. In reality, related table is equivalent to calculate and then the table, because they do the very same. So calculate table and related table are synonymous. You can use one instead of the other. But the feeling was that giving a name like related table made it simpler at the beginning to understand what is happening. But in reality, related table is totally useless as a function. It's just a nice name. Now, the last step is this one. I take sum of sales quantity, and I wish I had the right-click button, but I don't, so I copy on the clipboard. And then I create a new measure that I call sum of sales quantity. So sum of sales quantity is a measure that contains sum of sales quantity. There is no calculate anywhere. Sum of sales quantity, that's it. Now that I have the measure in test, I remove everything and I replace it with a call to the measure sum of sales quantity. What number is it going to appear based on what you know so far? Remember that there is no calculate anywhere.
But it's a measure, so it's still looking for filter context.
Yeah, but I'm waiting for people who do not know that. Go ahead. What number is going to appear there? Theoretically, you should see the total of all the sales because there is no calculate anywhere. But unfortunately, what you see are only the sales of the current product. And the reason is that whenever you call a measure from inside any piece of DAX code, there is an automatic calculate which is added by the engine just because it's a measure. So it's a measure, I will load calculate. And now that you have seen how the presence of calculate changes the semantics of your code, so if calculate is there, you get a number. If you remove calculate, you get a totally different number. So you know how important it is to know whether calculate appears somewhere in your code. And because it's automatically created, automatically added whenever you invoke a measure, that's the reason why I typically tell everybody, whenever you reference a column, put the table name in front of the column, and whenever you reference a measure, like in this case, never ever put the table name in front of the measure. Because when I look at this code, in this way, I read it as, oh, sum of sales quantity is a measure. Why that? Here in Power BI, I say because it's purport, but when you just look at code, you see it just because it doesn't have the table name in front of it. If it was a column, then I would have put there the table name, just to make sure that everybody understands that this is a column. There's no calculate there. So you can read it as a column. If it was a measure, I would have removed the table name. Trust me, this is extremely important, up to the point that I typically refuse to debug code if it doesn't follow this rule, because I see 30 or 50 lines of DAX code and they are impossible to read if you don't have a clear understanding of what is a measure and what is a column. Now let's go back to the slides. So whenever you write something like sum x over orders of sales amount, there is no table name here, so I read it as sum x over orders of calculate sales amount. Okay? Just because it's a measure, if sales amount is a measure. If sales amount is not a measure, that is not a problem. I would have written sales amount. Okay, how much time do I have? Oh, I have half an hour. That's more than enough. Well, not more than enough, but I will decide what to do. As an example, let's try to write together a simple measure that computes the daily average of sales. So I have a sales amount, and I want to compute the average of sales per day. Make sense? Let's go back to the demo machine and let's do that together. Just send me ideas. Let me remove some stuff like the number. Let me remove everything. So we can put the calendar here. Let's get rid of the date. So what I want to see here, I want to see the sales amount, which is here. And then I want to see another column that shows the average sold per day. How would you compute it?
A distinct count of the calendar table for days and then taking total sales divided by that number?
You can do better than that. The idea is not bad, but you can do better, I mean.
You're looking for the average sale price on that day?
No, for the average amount sold per day. So in a day will be the same number, but over a month will not be the sum of everything, but it will be the average.
For all days there are sales, or just residential per day? You have these times out.
Might be. What people typically answer, I'm glad, here everything is slightly different, is that do something like average over sales, sales amount, where is it? So computing the average over sales of sales amount as average sold per day. Then again, I have no idea where I put it. In the customer table, beautiful. The number that you see here is not the average sold per day, but it's the average amount per row. It's not per day. Okay? Another way of writing it is say, oh, you need to do that by day. So use an average X. You remember iterators. Yeah, no, it's wrong. And you do for every day, so you iterate over the date. And then you do a sum X over sales of sales quantity multiplied by sales net price or unit price, that is. This is iterating over date, and then for each date, it computing the sales quantity multiplied by the sales net price. And you get some number, but you can intuitively see that it doesn't make much sense. What's wrong here? Or what is the reason why this number is not the correct value? Louder.
Date isn't adopting the row context?
I didn't hear.
Oh, sorry. The date is not adopting the row context in that row?
Date is in the row context. I probably need to zoom. I'm iterating over the date. Date as the day level, so I'm doing that row by row. And for each row, I'm iterating over sales and computing quantity multiplied by price.
Yeah, but the filter context overrides.
The filter context?
Overrides.
What?
Overrides the date.
Overrides the date. So that it
What is that? Imagine that you are here in February 2007. What number is appearing there? How is it computed?
It's a average of averages. Averaging the sales for the week.
Unfortunately, I wish we had much more time, because this is one of the examples that I love to do to work more. But before we move further, I want to give you probably the most important point, the most important detail, which is how to debug and correct any DAX measure. So it's really a golden rule, which is harder to use than you expect. And it's a two-step rule. If the measure that you see does not return the value that you want, you need to follow these two steps. The first one is the hardest one, and it is stop thinking. Whatever you are doing, really stop doing that. Totally clear your mind, and then follow the measure in a very sheepy way without thinking too much, and asking yourself at every point what is the current filter context. So you will get an understanding of what is being computed in each part of the formula. So the first part is stop thinking at everything. It's not an average of an average. It's not it's computing or it's doing. No. Forget about everything and say, OK, the cell is the one where the mouse is pointing, February 2007. What is the filter context at that point? February 2007. Two columns. One is 2007, the other one is February. And that is the filter context. Then we do an average over the date. How many rows are visible in the date table? 28 rows. OK? 2007, yeah, it's not a leap year. So there are 28 rows in February. And so I'm iterating 28 times. Cool. Then for 28 times, I compute the sum x over sales. How many rows do I see in the sales table? Sum x is iterating, so how many iterations will it do? Louder.
28.
28 is the iteration of average x over date. Then inside there is another iteration by sum x, and sum x is iterating over sales.
So every single sale that falls within those 28 days.
Every single sale that falls within all of the 28 days.
Right.
So for 28 times, it's summing the sales of all February.
So it could be thousands of rows. It's just
Whatever number it is, the point is that even if sum x is executed inside average x, sum x sees all the sales that are visible in the current filter context, and nobody changed the filter context. So we are iterating by date, but since we are not changing the filter context, for 28 times we are computing the sales of all February. And of course the number makes no sense at all. What we need to do is say, oh, I want to iterate 28 times, and during each iteration I want to see only the sales of that given day. So I have a row context on the data, and I want to transform it into a filter context on the sales table. And you know who is able to do that? You simply put calculate here. And now the number makes much more sense. It's not perfect. I mean, you probably need to debug it a bit. And it's not yet perfect, but at least it makes a bit more sense. The problem is it takes some time to understand and make all of this stuff work. At the beginning, it's not easy. I remember when I was learning DAX, I had formulas that did not work, and of course there was nobody teaching it, so I had no idea how to understand what was happening. So I look at the formula, it computes some value with no meaning at all. I sent it here to Redmond, to the product team, saying the formula is not computing what I want. What's wrong? And after a few minutes, the formula came back with calculate somewhere. And that formula was perfect and working. And I was looking at it and saying, well, I don't know what is happening here. Now at least we have a theory, so we know what is happening. The point is that the theory is not so easy. At the beginning, it's pretty simple to get fooled by all this stuff. Then, after a while, it becomes simpler. Let's go back to the slides, please.
Quick question there. In the formula or the expression that you had before you used calculate, what was it actually calculating? Like what was the value actually? I know it was a bogus number, but how?
The formula we had a few seconds ago, the average sold per day.
Right, the wrong one, without the calculate function.
Oh, the one without calculate, it was computing for the average. For 28 times, it was computed the full sales, so it's basically computed the full sales divided by 28. No? Times 28 inside some x, but then it was doing an average x over data, so the average x was computing 28 times the same number, which was 28 times, I'm getting mad. We can write it down with Excel and get some meaning. No, I mean, we can try to understand exactly what number was that, but it's more an exercise than that. But the main point here, the main reason why I typically show these kind of examples is because what I want people to understand, I don't expect everybody here to be a master of evaluation context after just a few hours that you see the code. My main concern is making you understand that if you know the theory well, then you can look at the number and understand what it is being computed. If you don't, it might take time, but you can do that. If you just trust a generic understanding of the language without knowing the theory, you look at the number, it returns something which is totally crazy, and you have no idea of why that number is wrong. The same happens also for right numbers. You have a number, it's correct, but you have no idea whether that number will be correct in all the measures and all reports that your user will do. So understanding the theory is mandatory if you want to really trust your reports and understand what was happening.
Do you know if there's like an evaluate formula on the roadmap anywhere?
Sorry?
Is there an evaluate formula or evaluate measure on the roadmap anywhere, do you know?
What do you mean by evaluate?
Like in Excel, you can hit the evaluate formula button, you can step through the function.
No, I don't think they are going to do anything. I don't know whether they are planning to implement something like it. It would be nice to have it, yeah, because that way it would be extremely dynamic. Keep in mind that there is always a fight between Excel people and the engine people. Basically, the engine people want to keep everything extremely fast, whereas the Excel people want to keep everything extremely flexible, so let me do whatever I want. The goals of the two kind of people are very different. The engine need to work with tables with tens of billions of rows on multi-terabyte machines, while Excel users typically work with smaller models. So for them, speed is not an issue because everything is fast when you are with small models. But when you reach the billions, things start to be very different, and then you need to worry about performance. Functions like evaluate or dirty things like those are killer for performance. Okay. We have iterators. There are a lot of iterators: max-x, mix-x, average-x, product-x, concatenate-x, standard deviation, percentile, geometric mean. There are really a lot of them, and nearly all of them follow the same pattern. If you want to compute the average, the minimum, or the percentile over a table, you simply typically iterate it, use calculate to consolidate the raw context into a filter context, compute the value, and then you get the value that you want. Now, I have only a few minutes left. I don't have many slides, but there's no way I would need to run too fast to go to the end. So I just want to show you the basic introduction to time intelligence, just to have an idea of how time intelligence works. Because the good point about DAX is that once you learn evaluation context, row context, filter context, and all this stuff, you are done. There is nothing else that you need to learn. Everything else is just an application and some variation on the same theme. So all time intelligence is extremely simple to implement. I guess you know what time intelligence is. Say yes. Year to date, month to date, quarter to date, running total, all these kind of calculations are what we typically refer to as time intelligence. And in order to make them work, you need two things. Well, either you simply trust the new features which is coming in Power BI of automatic time intelligence, which I don't. I prefer to write the code by myself so I know what is happening. Otherwise, if you want to do time intelligence by yourself, then you need to write the code by yourself. Let's try, for example, to write a year to date, a very simple year to date, to see how time intelligence works. First of all, you need to have a calendar table. So if you want time intelligence to work, you need to have a table in the model that contains the calendar. That calendar need to have a few characteristics. It need to contain all the dates of the year. So it doesn't matter if you start selling in June, the 1st of January of that year need to be present, and all the days need to be there, no holes at all. even for vacation or whatever. No, 365 rows per each day. And that table needs to have a column inside, which is a daytime. That's all it's needed to build time intelligence. If you don't have such a table, you build it by yourself, using Excel, using SQL, or whatever you prefer, but you need such a table. And then to build, to compute year-to-date, let's start with something. We can do everything on the demo machine, and then we will see the slides maybe later. Let's get rid of average sold per day, and okay. Now, this is not what I want to see. I want to see, let me show in a matrix. I want to see the calendar, 2007, January, and then individual dates. And I have the sales here. Imagine that I want to compute a year-to-date. If I want to compute a value here for the 18th of January 2007, the number that will appear here is the sum of all the numbers that appeared before. Okay? If you think in Excel way, that is the previous number plus the current one, but you cannot do anything like that in DAX. What you can do is saying, oh, I have a filter context that contains only the 18th of January, and I want to replace it with another filter context that contains all the dates in the same year that happen to be before the 18th of January. And replacing the filter context, or creating a filter context that contains all the dates of the year up to the current date, I will be able to compute the value I want. Make sense? Since it's a too complex exercise, we can write it one step at a time. So we can create a new measure. Let's call it sales year-to-date. We start with calculate. Yeah, I know that. The measure we want to compute is always sales amount. Sales amount will compute the measure. And let's start with something simple, like a filter. Instead of computing the year-to-date, let's compute the sales between two dates. And we define the dates in a fixed way. So we develop it one step at a time. So we filter the date where the date is greater or equal. Where is greater or equal? Date 2007, I guess, 2007, 01, and at the same time, the date is less than 2007, 01, 18. Okay? So this is computing, This is computing a fixed value, and it will be the same value for all the rows. Make sense? Let's see what happens if we add it to the model. Doesn't seem to be correct, because it's showing values for the first 7 days of the year and then nothing else.
18 instead of 8.
Yeah, that is fine. If I use 18 here, it will show value for the first 18 months, but it's the same value. It's not a year-to-date. The problem is that I'm filtering date. That's not what I want to do. What I want to do is go out of the current filter context, filter all the dates, and then return me the two boundaries. Now it makes sense, and it shows the values also for 2005. That is fine, because for any date, it always shows the sum of, well, there are just too many of them. Trust me, this is the sum of the first 18 or 17 days of 2007. So as a technique, it works. The idea is not bad. The point is that what I don't want these two values to be fixed. I want these two values to be dynamic and change depending on what is happening in my report. Okay? So I don't want, I need to replace the upper and the lower boundary with something which is dynamic. To do that, let me remove this measure for 1 second. Let's create a new measure, and we call it max date, which is equal to max of date. And then if you put max date in the pivot table, you see that for each day it shows the current day. But then at the month level, it shows the end of the month, because it's always the maximum date. So in our original measure, sales year to date, we can replace this with max of date. And now, if I put sales year to date here, okay, I see a number which has the maximum, the limit on the top, which is corrected. Unfortunately, I don't have time to go through all the details, but the point is, if you, for the minimum boundary, you basically create a date, which is a date that has the year of the maximum of the date, and then 1, 1. So this is returning all the dates between the 1st of January of the current year and the last visible date in the context. And once you compute the measure in this way, now sales year to date shows for the 1st of January the same value, then a different value, which is the sum of these two, then a different value, maybe zooming it would help, and then this number goes on growing, always adding values to the previous row. Make sense? So the point, and unfortunately, as I told you, I'm already very, very late. So let's go to the slides, and we go to the conclusion. What I wanted to show you was not, let's go through the slide, please. What I wanted to show you is that computing something simple like a year to date, if you understood evaluation context, filter context, and all this stuff, is extremely simple. Whereas if you didn't understand evaluation context, row context, and filter context, yeah, you can trust a standard time intelligence function and everything will work, but you will not be able to do really complex calculations. As I told you, unfortunately, I don't have time to run through all the demos about time intelligence, and probably you're already tired enough after 2 hours of DAX evaluation context and stuff, so it's not worth going into more details. The point is, if you are new to DAX, remember that there is only one thing that you need to focus on, which is evaluation context, row context, filter context, and calculate. Spend your time there, learn them the right way, and then time intelligence and everything else is pretty simple to do. If you are already using DAX since a while, then that was just a reminder to play with evaluation context and this stuff. I already said at the beginning, if you're interested in all this stuff, and a lot more about DAX, probably too much for nearly everybody. On that book, you will find a lot of details about the engine, the internals, plus many more details about strange behaviors of Calculate. As I told you, we have seen the introduction of Calculate. For very complex measures or very complex scenario, the scenario is a bit more complex and a bit more advanced, so it requires more time. Now I think I'm extremely late, so thank you for attending, everybody, and